Okay, checking my audio. 1, 2, 3. It would help if I actually turned on my sound so I can hear my levels. Okay, I think we're in, we're good. So let's get started. Let's see here. Fresh reboot. So size things up for streaming. And then load up what we're working on today. Oh, so last week, basically laid out the bookshelf, the tiles, and the letters to fit. So if we do something like this, let's go ahead and do a full clean release build. We'll take a look at how it looks. Because what we're looking for is clarity. We want to know if the user can easily see everything they need to see. Today we'll do some more layout. I think the bookshelf is in pretty good shape. We might change a few dimensions here and there. But now that is less expensive than it was to do. It's a couple of scripts and we're running and good to go. But I don't know if I can shrink those letters anymore. And maintain readability. Just a moment. Okay. All right, so the release build is done. Source build, release build. Let's take a look. Yeah, that one grew quite a bit. We're putting more art assets in. Some of them will also come out, but that was a big jump this week. But that's besides the point. So let's run it. So we can just look at the layout. So I've got things set to the biggest size supported. And if we go to game, not a game, sandbox. Oh, this is a release build. Okay, well let's do a quick play. We're running at 20 frames per second or 2400. 25, 24, 2000, 2200. I'd say we could probably call that 2200, right? It's all over there today. Sheesh, what's going on? Let's call it 2200 syrup. Is that how you spell that? SIRUP. Sugar house syrup, molasses, or maple syrup. What? I thought you spelled it with a Y. This is alternative spelling? Variant of syrup. Okay. Okay, so it is just alternate spelling. Crazy. Alright, so that's good. Da, da, da. So we put that in at like 22 frames per second. Let's go back to our debug build so we have our sandbox. Because we got to look at the sandbox. The sandbox is where we're prototyping our new layout. Everything will be laid out to pixel specifications so that when we do our animations, everything will line up. This is all part of the polishing phase. The game is done. It's playable, it's workable. The art's crap. And the animations need to be not cleaned up. They need to be everything is nice going over for clarity, for snappiness, make sure everything feels responsive. So we're in the polishing phase. So we're going to get pixel perfect layout. And then see where we go from there. Instead of the release build, we want to run the debug build. There's our sandbox. And that's what we came up with. It's not bad. My fear right now is the chalkboard won't fit well. This bookcase is really wide. But I don't know if I can shrink it and retain the size of the letters like this. Like if we go to a small size, which you might not be able to see very well as a contrast. I would argue those letters need to space out a little bit more. So let's go back to sandbox. Letter tile spacing factor. Um, hmm. Make the blocks smaller. Does shrink a lot of things. Hey, Javest. My weekend was good. My weekend was good. Had to do a bit of running around on Saturday. The rest of the weekend was pretty quiet. I'm trying to think if there was anything noteworthy. Um, no, I don't think anything noteworthy happened. But yeah, it was nice and restful. I was looking at my code metrics code and have almost decided that I need to go revisit some old project management code that I wrote for streamlining things for complicated build processes. Let me just put that in there, but probably not going to do that on the stream. Don't have time for that. It was kind of a cool little setup I had going. Definitely will have to revisit it. So I was looking at that old code. How was your weekend? Anything good? Anything new, interesting, or just restful? 5 before. Maybe we just need to add an offset. Maybe. Maybe. Get any work done on your own web page yet? Are you gonna do a blog and some things? Okay, that's a lot closer. Maybe go to like 1.5 pixel spacing. Okay, that's on the small size. Whoa. So it's really not scaling well with the screen changing size. Now it's overspacing. There's a factor somewhere that I'm not liking. Guess letter size. I guess letter size is the font. Oh, let's see here. Point size. This integer. It's an integer. Weekend was good. Nice autumn weather on Saturday. Sunny, about 12 degrees Celsius. Nice. In the city, had some coffee, just taking it easy. Nice. Very good. Working on my own webpage today. Some front end. Okay, cool, cool. And how's your, let's see, your new house? How's that looking? Do you get things out of boxes, or you're moving sometime? Week or two maybe? Size is all in integers. That's probably where most of our errors coming from now. And that makes me sad. We need to make that a float. We can. I don't know if that changes much though. Okay, problem one. What if we do this? Set text, or set text size. What if we round this? Oops. Moving in about 3 weeks. Okay, this is 3 weeks out. Cool, cool. That'll be great. So you're putting things in boxes. Stage. Yep. Yep, yep. Very good. Very good. I don't know. We're just gonna throw a number in. See what happens. It'll either be too much or too little. That's too far. In fact, it's almost double too far. Oh. He doesn't scale with that at all. Just playing around for a little bit, warming up, getting fired up for the week. Okay. Okay, that looks pretty good. Now if we shrink things down, we're not taking into account the font size, and that is actually pretty close. It's mostly the number 3 that looks off to me. Maybe that's okay. Is it because of the space? Maybe it's because of space. Hold on. Char spacing. Oh. It is added in to a space. Shoot. Alright. Fine. Thought maybe I'd forgotten to add this term in when we were doing a space, but we are. Still, I think that's better. Okay. So, what we're doing today. The game is playable over here, but we're going into our sandbox and doing layout. So there needs to be a chalkboard. So I need to remember the width of that bookshelf. Right there. Set a rectangle to our shelf width. Which is 1004. If we're at 1920, so that's a little bit over half. I would like to whittle that down just a teeny bit so that the bookshelf is less than half the width. In fact, what width do I want? We go 1920, oops, the maximum width. And it needs to lose, let's say, 3 times 20 pixels for the 2 margins and then the space between the bookshelf and the blackboard. 320. Then we want half of that. It'd be nice if my bookshelf was 930 pixels wide. We'll shoot 930. 930. It kind of doesn't matter because we're laying out the. So let's see, the blackboard. Blackboard. Let's go to Scratch. Let's just sketch something out real quick. The blackboard. Needs to be 4 by 3. aspect ratio. The blackboard, I do want to take up the whole screen sometimes. So 1920 by 1440 should be fine when we do the actual output. And if that only has 930 in width in the game scene, we're going to use that blackboard in multiple scenes. Then it actually needs to be let's see here, 4/3. So it's actually, let's see here, 3/4 times 920. 1920. 3/4 is 0.75. Go to 930. 6975. And we need to fit from our game. You see we have 1, 2, 3, 4, 5 rows. 1, 2, 3, 4, 5, 6, 7 columns. And some buttons on the side. Um, 2, 3, 4, 5, 6, 7. Seven letter columns plus one button column. We'll come to those eventually. And 5 letter rows. So it's 930, enough to fit the 7 letter columns at the font size we need. That's kind of the question. Every other use of the blackboard doesn't really matter. But I do think the blackboard needs 50% of the screen. So we need to shrink our bookcase a little bit. 930. But anyway, we need to set up our new week. My bad. Getting ahead of ourselves here. Oops. I believe I've been doing this for 14 weeks. It's crazy. Ooh, and we're almost into October. That'll be nice. I've been looking forward to October 31st. Because I'm going to eat donuts on Halloween. There's nothing you can do to stop me. Basically, I've been on a bit of a weight loss diet thing since, what, May? Now I'm ready for real donuts. Nope, I'm doing it for donut day. You have to have donuts and cider with Wallace and Gromit and the Curse of the Were Rabbit. That's tradition. Then I'll get back on the wagon for like 3 whole weeks. And then Thanksgiving will happen. Then I'm off the wagon again. But to be fair, I have undone 6 years of damage in 6 months, so not too shabby. Sorely tempted by cinnamon rolls on Saturday. Yeah. Although you're close to being done, sort of. As long as you schedule your cinnamon rolls, you're okay, right? Isn't that the rule? Something like that. $930 pixels wide. I'd like it to be narrower, but I don't think I can. Other than even that. Well, I mean, once in a while, right? Yeah. Good. Maybe we should get together and do something for Halloween with the kids or something. So 1920 by 1440. And this was the important number here. Agreed. Yes. Oh, by the way, I think I'm headed up to Grandpa's house on Friday at 4. Take the kids camping in Grandpa's backyard. So, JTL, if you're interested, you're certainly invited to join or send along your kids, whatever. But I should have everyone from let's see here, what is that child number 4, child 4 down. Probably just do hot dogs and s'mores. Although I think I'm gonna bring a Dutch oven and make myself some fajitas. So short stream on Friday. That's the new plan, and I'm not varying from it this time. Set in stone. It's planned. It's on the schedule. Okay, so there's my plan for the day. And honestly, since we spent all that time writing code last week to lay out our graphics for us, oops, it shouldn't be that hard anymore, I think. I should be able to resize and scale and move things a bit as I need to. Okay. Sounds good. Number 4 will probably enjoy that. I'd be happy to pitch in on fajitas. I don't know, it just sounded so good. And we've got some steaks we still need to get rid of before we buy up a new cow in November. So yeah, don't worry about that. Although, yeah, I don't know. Everything's so fluid these days. Because I think, yeah, fajitas are probably good. Okay, so just out of curiosity for myself, well, let's just see how it fits. Let's just go. Let's just do it. So we are going to go to Blackboard needs okay. So we're gonna shrink our bookcase a little bit. That may just involve well, I have a couple of ideas. Or we might be able to steal some space. So if we go to let's quit this. Put more shell. CD into tools. What we really care about is the math. Something mathy was in there. Layout math. Pi. Okay. Bunch of stuff. Okay. The letter block's depth is 10 pixels. What if we just make that 7.5? The spacing down to 3. Let's just take a pixel off of every font and font size. Just see what that does to the overall shelf layout. Lay out the shelf. Shelf size. Oh, the shelf computed size is much closer to the width we want. I said 930. Wow, that's still not very much. Good heavens, let's shrink the font a bit more then. Let's go all the way to 50. I think we'll still be okay. Whoa, 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 whoa. Right there. Ooh, 918. That's closer. Can we make it 930? Um, oh, perfect. There's our 930. Okay, so if we just shrink the font size and give a little tiny bit less width to each tile, or depth rather, we hit our target. So in sandbox scene, these are the new numbers. Shelf WH extrude, wall thickness, bottom thickness, word horizontal and vertical spacing. Those just all go away. That's the shelf. So let's grab everything from here down. Oh, I need an Inkscape open. Oh, the bots have struck already. It's a Monday. It's too early for bots. I can't handle bots this early. Oh, yeah. Inkscape. For whatever reason, I installed it, but searching on the start menu won't bring it up. So just a moment while I dig it up the hard way. And then I need to remember to pin it to my darn toolbar. Because modern computers suck. It's like they don't consider the user experience anymore. Maddening. Oh look, here's Inkscape. I found it. I don't know why Windows couldn't find it. Bunch of morons. So just a moment while that boots up. And then we will pin it and then share it. So hit the taskbar, thank you. Pat. Hey Pat, what's up? We're doing good, doing good. How are you doing? Anything exciting over your weekend? Oh, this feels too big. Just there we go. Now, where's the old OBS? Here we are. Inkscape. Hey, there it is. Okay, now extensions, render, simple Inkscape scripting, paste, apply. That should redo the shelf. Maybe. Oh, there we go. All right. So there's our new layout with the new spacings. Page 2. Selection, I guess. Okay. Now that should have outputted a file with new sizes. Implemented hot reloading into that Wordle game. Nice, nice. Hot reloading is an interesting topic. I know hot reloading is basically a built-in automatic feature in Lisp. But most modern languages, it's not trivial. It's not hard, but like there's just so many different little corner case gotchas. You have to know which sections of the code are safe to hot reload, which ones aren't. But yep, cool, cool. Cooking, huh? I do like cooking. Well, I like eating cooking. Okay, so I think that's our new bookshelf. And it should have outputted everything as I would expect on bookshelf.png. So, go over here. There we go. Now you can see the script as well. So we're interested in is probably generated in assets, images, bookshelf. So there's that one. The layout scene elements. I'm going to bring the new bookshelf in and see if it's smaller. We want it 930 pixels wide, I think. So we've sacrificed some font size. So there's that one. We're going to drag the bookshelf on. And there it is. It's not that much of a difference in size, but it is a different size. So we're going to hide this one. We're going to drag this line up to 1150. Sure. All right, now we're going to export our block, which is a much simpler piece. So this will just get updated. I know it's not scaled properly. We'll probably do something about that. Oops. Right now we're just switching between windows so much it's not worth my while to lay it out again, I think. So the font size, all of this stuff probably is different now. So we come down to 50. The tile spacing, letter tile spacing. Consider font sizes taking floats. That is a possibility. Each font size you have is actually scaled by 32 or 64 or something, so it'll handle fractional font sizes okay. I don't know if I want to dig into that right now. So we take that as a, if we can't get things to line up properly, we'll go revisit that. So our to-do list. Back to get proper layout of text may require floating point support. I don't think it'll be hard to do if you want it. Just a thought. Okay, so we got our bookshelf. We shell. Here's our Inkscape script. So we go to Inkscape, delete everything, paste in our new script, apply. There it is. And the letter block, we should just be able to drag it in here and move it to there. That's mostly it. So we export this over scene elements. We did know the sizes, so when we go over to, I think that's mostly it for the graphical size. Let's go back to Emacs mode and hide Inkscape. Assets, images. What matters here is the bookshelf width and height, which I can take from the shell. It's like the block size is slightly different. Total size. Oof. 55. $56. And this one has a size of 930 now. And 119. Okay. Gonna pause for a short restroom break. and we'll get right back to it. So we've added those updated values. The other thing we need to do in here is this is now, I think, 50. So for those who are newer graphically not interested, I'm basically saying within this image, there's a rectangle here at 0, 0. That's 930 wide and 1019 pixels tall that you can treat as a special area within this image. And it's going to be called a bookshelf. And then the block, same thing. It starts at x0, 1050 down from the top. It's 56 pixels wide and tall. I want you to call it block. So this is what's called a UV coordinate system. So this will embed all of that information into my actual code. Embed PNGs. Sandbox. Yeah, so this already has the 930 and 1019. So we can compile this one. We should get all of our new image data in there without too much trouble. Block extrude height. Oh. And the spacing. I did not put that either. Okay, well, we have to fix that script just a tiny bit. There it is. We need that extrude. And we only care about the width, the height. Huh. Okay, well, it's only the height. Spacing. We need those extreme numbers. Block extrude height. width. This one is height, width, width. There we go. Now we'll never have to do that again. Source builds debug. Okay, so that works. The letter spacings aren't too bad. If I make this huge, ooh, yeah, those letters overscaled just a bit much. But the bookshelf now has, I think, come in below the width that we want. That letter spacing. We just guessed the letter spacing though, so like 14. So we can get that scale, that spacing just a little bit better. This is oh, that's pretty good on the big. Not bad. The H is just a little bit overshot. C's are like 1 pixel over, yeah, a little bit overshooting. A little bit. How does it look when we shrink it? Okay. All right. Okay, so that's basically that. All right, we need a blackboard. Computed a desired bookshelf width to allow 50-50 split with bookshelf, with chalkboard and spacing. They should both be about 930 pixels wide. Updated some values in the bookshelf block to regenerate an appropriately sized texture. Letter layout needs some work. Maybe fractional font sizes support. Again, accumulation of error over integer truncation might be our problem there. Okay, sounds done. So let's see here. Oh, no, not what we wanted. stage. Assets, images, bookshelf. This is literally just a temporary file. We don't want to store it. Images, layout, scene elements, journal, to do, image warehouse, sandbox. Okay, that all looks good. So git status. Updated bookshelf size. Boom. Now we need a little chalkboard. So if we're going to, because the chalkboard is the next thing that the user is going to interact with a lot. We need it to be clear. We need it to have enough room. So go to layout math. A letter block. Oh, nice. We did have that cube helper. Is there any else where we need to remove chunks? Yeah, here's another cube we can remove. We basically created some convenience functions for that stuff. Okay. So we start with the letter block. As our starting point. Let's go make this our main function here. Ooh, control C, there we go. I'm not sure I'm using these anymore. Oh, we are. We are not. Right guideline no longer does what it used to do. So that's actually a bad name. Oof. To do. Remove. To do. Right guideline no longer matters at all. It does nothing. Okay. So we do this. I think this is the right answer. We just need to put the comments in like so. Just do some cleanup here. So Alt Z quote. That makes our code much easier to read. Align regex. Boom. Easy. Right, bookshelf. All right. We're going to search for right guide. Oh, okay. Typo. Search for right guide line. See quote. Search for quote. Kill it. Boom. Okay. Another value here. Let's see here. Guess width equals and then we can line this. Oh, we can line this up. Boom. There we go. We now have clean layout, better comments, so much easier to read. And then we copied letter block. We need to lay out the bookshelf. Or not the bookshelf, the chalkboard. Chalkboard, we need light brown, mid brown, and a dark brown. I don't know what colors, we'll just leave those the same for now. The width in pixels shall be 1920 by 1440. The depth can be 8 pixels plus 12 pixels. Oh wait, this is the front face anyways. It's okay if the bookshelf squishes a teeny tiny amount over this size. Oof, let me think. I don't have any spacing, but we do have slat width. Which can be, I don't know, 24? Okay, the size. This is the tricky part. I don't know if I want to compute size this way. Basically, just want to start seeing how things look. So, where are we at here? Cheap viewers. Yeah. Always sad. So what we're looking for here, I'm gonna scratch. would be nice. We can get something like this. And then each of these will have their own little depth thing. So the chalkboard has some depth to it. So how would I go about doing that? For just layout, we don't care about these angles. Like when we do the final art, somebody will probably will draw in those angles. Ready to go have strong words with my children about how they're behaving while they're supposed to be doing homeschooling. So what do I think about that? So what we need to do is lay out okay, here's a simplification we could do. We could do this. There are no angles. Then we can just lay everything out as rectangles and it will look okay. Something like that. We need to make this look more like a chalk tray than a slatted board. However, this does eat away from our letter space. But it doesn't need to be much. I think this one will look more old school. But what I like is that I think it'll let me give some depth to this chunk. You'll see like the offset to the chalkboard, but like the black slate here, which I like. So sort of like on the let's see here. Not that one. So the sandbox. Maybe you can't see it very well. Maybe if I make it, oops, make it big. Come into the sandbox. You probably can't see it best. So let's see if I can make it bigger for you. Oof, that's stretching, whatever. If you can see, there's like this little offset between the edge of the bookshelf and the tiles, though they're not like flush with the front face, they're pushed back in a little bit. Same up here, there's a little tiny space there. I think I want that with that blackboard, and that'll be easier to do if I let everything out in blocks. I guess I don't have to extrude any, like I don't want to waste any space. So it's gonna have to fit right in here. Okay. Okay. So where do I want to go with this? I want to even the depth. Board. Get chalkboard. Used to be 1920 by 1440. Oh no. This is the up until now. These are meant the front face width and height. So the the part that's perpendicular to the camera. Okay, okay. So I have to do a little bit of thinking here. Target width equals 1920. Target height is 1440. And over here, we get our depth. This equals target width. Oops. Minus ISO add width self.depth. I think that's how we have to do this. Everything else should be derivable from those constants. So the size should be straightforward. So dot width times ISO add width self dot height pixels times ISO add height. plus 0.3f by margin 0.3f. 0.2f by 0.2f. Chalkboard. Or dot size. Okay. The reason for this computed size is because what we want our size to be is derived from blocks and the number of blocks that we have to fit on there. So, okay. Let's just see what chalkboard size says. For tools. Chalkboard size. Huh. It is wrong. Just wrong. It is not 16,000 pixels. Oh, times. Good heavens. Plus. Yeah, we don't multiply. So that's 1920 by 1440. That's perfect. That is the aspect ratio we want. Okay. So we now know the dimensions of our front face. We need to write out, let's see here, there's no computed size. That's not useful. Is this in block? I don't think we actually use that anywhere. Oh, we do. We do. Okay, fair enough. Computed width. And computed height. That's basically what we just said. Okay. Right, Inkscape header. The cube. Writing Inkscape cube. the export. So this is the part here that we need to change the most. It is taking, oh. So all we have to do is tell it what X, Y, width, height, and extrude width, height are for this section. And it will work. Okay. Yeah, we'll come back to that. We'll write our header. That should be fine. And our export. That should be fine. So before we can write this, we're going to say top frame. So it does front, top, right. I want it more like the bookshelf. We're going to use the bookshelf colors, I think. Okay, bookshelf. Where's the colors? There they are. Don't need the very dark, I think. We want the, actually, light, mid, light, mid, dark. We really only need these, so we can call them mid and dark. Okay. We want the front face to be mid, top face to be light, front, top, then the right side. Mid, light, dark. That's kind of the pattern we want to go with. We need to tell it what width and height are, so W equals some number. For X. Zero. Y will be 0. Width will be width, height, depth. Nope, just extrude. The width will be one slat. Well, it'll be the full run of the front face. So 0.3 float of whatever. Inkscape header styles. That's fine. The extrude width and height are fine. X, Y is fine. Width, height. So we will have extrude width and height. So it will be the height will be slat width. width height of the top frame. Width doesn't even really need to change. Well, the bottom frame. The width is the same, the height is the same. The X is the same, the Y is different. Because we want to draw bottom to top when we're doing isometric. Or front, back to front, either way. This is the way that the things will overlap. So we'll start with the bottom frame. Then we'll do 2 vertical frames. Then we'll do the top frame, and that should box everything in nicely. So the bottom frame. Will be our height minus, I think just our overall height. Minus our slat height. Right? So we come down to the bottom of this shelf. Then we're going to come up 1 width of the slat. So I should draw 2 frames, vertical top and bottom. I think. No, W plus extrude, H plus extrude. So I have to do that before we do the export, since we're changing things. We don't really need to simulate the layout at all. Because it's all just computed. All right, let's see what this does. Okay, computed width is not defined. And yet, here we are. Oh. Okay. So 342 self dot. Okay. board. Inkscape. All right, so XY styles, extrude width and height. That's basically the whole board's overall rectangular setup. Width, slat width. So maybe we do that. Mm. Okay. Width isn't needed. Technically, this X and Y are not needed. Oh wait, this is the bottom layer, so yeah, it is necessary. We need Y and H. And we're gonna do some vertical things here. Okay. So we do have to reset our Y and H and our width. So this is all gonna be needed. Face width. Face height. Then Y becomes face height minus slat width. Then our height is our face slat width. Then we draw the bottom frame. Width equals face width. Height equals slat width. Or flat width height equals the slat width. Okay. All right, what do you think about that? How are we looking? Okay. Get our XY offset, get our styles, we have the extrude width and height. Okay. So now we take Y and H, draw out the bottom frame, which is 3 polygons, and then group it. Then we get new X, Y width heights, and draw out another 3 polygons and group them down. Then what's this? 376. Oops. Good under that. Okay. Now run it, and that's not too bad. Let's just see what happens up to here. All right. Let's see. We're going to come over here and apply. See what happens. He didn't like it. Face width is not defined. Okay, fair enough. Okay. There. Those are the horizontal slats. Makes me want to make the slats bigger, but we'll hold off on that for now. Okay, cool. Part 1. Come together. Now we need those vertical slats. So back to Emacs mode. So this is going to be the left frame. Its X and Y will remain, well, its X will go away. The width will be the slat width, and the height will be our face height. Actually, ooh, that's a good question. Y. The top of the and maybe I'm overthinking this too much, but our height is going to be our face height minus 2 times slat width, which means our Y has to be our extrude height times 2 plus our Y offset two and the slat width. Basically, it takes up the isometric extension for the slat width, for the slat, and the top slat, and then the extrusion for those vertical slats. That's 2 extrusions plus the Y offset plus our slat width. I think that's that width and height. And the default X was fine here. So let's try the left brain. If that works, then we just have to do X translation of it all. Okay. So go to yield Inkscape, paste it all in, apply. There it is. That close and close. Super close. I guess we don't take into account that extra extrude height, so we just need to move that once. Okay. In fact, we can find that and just try it out here. 1. Yeah. Okay, that lines up. Ooh, that does not line up where I want. So the height that we're keeping here plus extrude height there it is. Now it lines up the way we want. Cool. We just do that for the other side. I have to make those changes here. So and the height plus extrude height. There we go. Now we just need to update the X equals face width minus slat width. And then dump right frame. So we're going to do it in this order. The bottom one, its extrusion is partially overwritten by the vertical slats. So the vertical slats then have to be all updated to draw up and down, but they don't overlap with anything else. So they can just translate over the X and be done. Dead simple. But then when we draw the top frame, which partially obscures the two vertical slats extrusion at the top, we draw this one last. So it has to reset all X, Y, width, and height for the slat. I think that's it. So we run this. Ooh, yeah, whatever. Delete, delete, paste everything, and try it. Oh, look at that. We've got a chalkboard outline. So it's 930, 450. There are 7, 8 plus 9, 17 columns. Oof. So if it's 930, there are 17 columns. So why do I say 17 columns? When we lay out 7 letters per column plus a button column, that's 8 columns. But I also want like 1 letter's worth of spacing between each one. So that's 9 columns, 1 on either side and 1 in between each of them. So that's 17 columns over that height, over that width. And that's 54 pixels per letter allowed. That's only if it's 930. If we roughly have that, it's about 27 pixels per letter. So maybe we need a slightly different margin between the letters. And that doesn't have anything to do with the slats. Like, it would be nice, I think, if the slat width was more. Just to see how it looks. I think this would look better. So let's just see that. I think that looks better. Oof, okay. Now we need the black chalkboard, which will be a simple rectangle offset halfway into the frame. Ooh, interesting. So the trick is it has to do bottom, left, chalk, right, top. We don't have to do it that way. We could math things a bit more, but I think that might be the way we want to do it. Okay. So back into Emacs mode. Which is what? I said bottom left. Is where the chalk would go. Or the slate. To slate. So we need a color. We go with like one of the, well, we don't want to go with green. We want to go with very, very dark. So like, um, something. Okay. Our slate is going to override all that. So it needs to be, these colors do not matter. All the edges will be hidden. Oh wait, so we don't actually have to do that. Okay, so that actually simplifies things a lot. Good. Inkscape polygon, top, style, and then a list of points. That's what we need. Oh wow. I forget what top is. Inkscape polygon, object, name. There it is. Object name. Slate. Style name. Slate. And then a bunch of point pairs. So something like a slate. Let's see here. X offset plus extrude width divided by 2. And the Y is extrude height plus the slat width. So the top edge, down the height, down the slat width, minus 1/2 of an extrude width. So it's actually extrude height divided by 2 plus the slat width. Look. I can write some other stuff out. Print slate X equals this. Slate Y equals that. Okay, now we need slate width and height, which is base width minus 2 times slat width slate height, base height minus that much. Now from here it's actually gets easy. So we go from slate x, slate y, everything will be relative to those. So 2, 3, okay, 4 points. Slate x plus slate width plus slate width plus slate height. Okay, in theory, I should just output a single polygon. Named slate. What are the odds? All right, let's try it out. See what we get. Didn't crash, that's always good. Okay. Now, moment of truth. Need everything. Paste and apply. Well, that there is a slate color. And it is in the wrong position. So I have to subtract half of the extrude, not add half the extrude width. That'll fix the y. The x, I think it's just offset, so overall that's pretty close. All right, let's go fix that real quick. Minus x offset plus a slat width. Okay. Try that. Apply. Oh no. So close. What happened to our Y? That's way worse. Is this dark enough of a gray? We may have to make it closer to black. What do we do to our y-axis? Extrude height divide by 2. Plus slat width. I see what I've got the terms backwards in my head. Here we go. Minus extrude width divided by 2. Oh, there we go. That's what we're looking for. Now we have just that little touch of depth. But that slate color needs to change. Oh, okay. It's not quite black, but it's a lot closer. Okay, I'm basically happy with all of that. So let's go to our, clean up our Python here, run it one more time. So I said slate wide is this. 10, 10, 10. All right, we run it. And then we're just going to copy the whole output. We could dump it to a file, but you know, good writing here. Go over to Inkscape, delete, paste, apply. This should output our blackboard right here. Chalkboard we might just leave alone as its own thing, not put it into this texture. It's wider. Oh, but the size is not a power of 2. Oh, doggone. So we still have to go through a small transformation phase. Boom. Oh, oh, oh. That doesn't look like the right size at all. How curious. I mean, this one, delete layer. We did not look at that. Oh, we need to reapply the W and the H and do all that. Okay. Those back. Plus extrude width. Plus extrude height. There we go. All right, anything else? Okay, so when I write Inkscape export, export the area of the drawing. That's what's gonna prevent me from doing this in one single stage. Oh no, it does one. It'll add the extrude stuff. So actually, It's just this. Okay. Get all that. Get all that. Paste in the new script. Run it. Oh, what? It bash. Come in. Okay, well that's practically useless. Okay. Oh. Okay. If we've selected the right amount now. We now have our chalkboard. It should be exported. So I'm thinking maybe what we need are two scene elements textures, which gives us lots of room to play with more elements because we still have to fit a table. The journals. Okay, so we're gonna do this. Oops. Let's save this one. We're gonna close it so I can rename it, which we'll do using Git. I know I'm still not like gone into proper size mode, but like, we're just switching too many windows here to bother with that. So cd out of tools, git move assets images. Assets images, layout scene elements. We will move to assets images layout scene elements 1. Now we can create a new one here. 1920 by 1920. Let's see, those are not powers of 2, so we want 2048 and 2048. I hate that that's the default. Okay. Now we can bring in the chalkboard. Move it to 0, 0. Now we have all this extra room to add more scene stuff. But that doesn't look too bad. Not too bad. Considering. Okay, so we're gonna save that. The active projects, word sleuth, assets, images, latency out elements, but number 2. Save. Which means we also need to move scene elements to scene elements 1. Git move assets images scene elements 1. Now this one can export as scene elements 2. Okay. That's going to break a whole bunch of stuff. So we're going to go back in Emacs mode. We're going to fix it. or something. Scene elements 1, scene elements 1. Scene elements 2, scene elements 2. You have a UV, we're going to specify it as a rectangle called chalkboard. 0, 0, 1920, 1440. So that's just the size of it, that's all. Scene elements. There we go. Lastly, tools bin dot slash bed and jeans. Definition missing rectangle values for scene elements 2. Give you a rectangle called chalkboard. XY width height. Huh. What does it mean by that? I'm just going to be able to get rid of these, since we're not testing those anymore. Buttons used up a lot of UVs. Oh, I'll bet it's because there wasn't a space in between. That's probably why. There we go. Okay. Sandboxing. Let's just run a quick clean. Make sure we're on, not a clean, just a quick build. Just to see what's it doing here. Source builds, debug, sleuth. Okay, just make sure that it. Ah! Incorrect. What happened? Oh, well, let's see. Let's do that. Let's go to CD tools bin dot slash embed PNGs. Well, let's do a full clean. This has happened before. The last time this fixed it, so clean and debug. Here we go. 30 plus 40. Okay. Okay. Nothing's broken. Good. Now, sandbox. We're going to add a new text quad called m_chalkboard. Chalkboard width will be equal to scale against width by what I'd say 930. That's what I'm allowed per space. Chalkboard height. Is that? Okay. Set texture. Scene elements 2. Set our UV to whatever we called it. Chocolate fit. Okay. So we're at margin. Plus shelf width plus margin. The height can be this, the y-axis can be the same. And then it's chalkboard width, chalkboard height. Okay. Oops. If we've done our math right, that should put it in roughly the right place. Render chalkboard. Here we go. To see how we did. Kind of looking excited to the layout portion being done. Really isn't my ball of wax. I'm not probably over mathing things that an artist would be like, oh, I just kind of feel it out and it'll look fine. But, you know. Nobody ever paid me for my math skill or my art skills. Okay. Hey, there is a chalkboard. That takes up an awful lot of our room. I'm okay with that because it is an important element. We need a table with 4 notebooks on. So I'm thinking the table is actually going to be like, we're not going to actually see the legs of the table at all, just the top surface, which makes our lives easier. Okay, so if we shrink this down to the smallest, it is still identifiable as a chalkboard, I think. So next thing we got to do is lay out a bunch of letters. See that inner edge is not as visible here, that separation between the chalk slate and the frame. But I think it's a nice touch to have that little tiny bit of offset. Kind of see it. Maybe it's not worth it. Well, here's the other thing. This is going to get big. When we're at the main scene, it'll actually be just the chalkboard, right? The chalkboard will be our background here. So the fact that it's small here is fine. Okay, so left letters and buttons. Make sure those all fit the way we want. Okay, this is good progress. So in here, we do have a blackboard. Laid out a basic blackboard to scale nicely from 930 by, oh geez, 697.5 to 1920 by 1440 is laid out in the sandbox as if in the game scene. Still need to add the letters to it, make sure that the letter spacing and the letter sizes are good enough. Okay. We're going to add everything, but we're going to remove 3 things. Get store staged of assets, images, bookshelf, chalkboard, and the letter block. There we go. Added chalkboard to test layout in sandbox. Okay, so we're gonna do letter layout next. Brief restroom break. Yes, Stravest, thanks for coming back. Thanks for coming. You sleep well. Have a wonderful evening. The rest of you, I'm going to run a quick errand for my wife online, so I'll just be at my keyboard, but not focused on this work for just a minute. All right. Okay. I think that's it for my honeydew list. All right. So chalkboard fits in there. The question is, how big can I make the text, and how readable can the text get? So let's do a little bit of math here. This layout is less important other than the fact that we need a certain amount of room. just for good visibility. Nothing here needs to particularly lay out in a particular way. Um, what we want is our blackboard has a particular width across its face, which is a number we know. From up here. There we are. Face width and face height. And we have a slat width. But these are not scaled down to the 930 width and height. These are the numbers we really need inside of our sandbox. What do we put in our sandbox scene for that? We kind of just need that, right? We need a chalkboard face width. Scale factor actually gets a little bit interesting. Board scale factor equals 930 over 1920. So talk about the face width. Talk about this width times the board scale factor. Okay. And the chalkboard slat width times the board scale factor. Is that most of what I need? Surely we can compute a few more things that are useful here. Oops. Oh, come on. What am I doing here? There we go. There we go. Chalkboard. Letter width. And spacing. I don't want the spacing necessarily tied to letter width. I want some control over that. Oops. Look, there we go. Letter size, we're going to declare them all to be rectangular. For now, we're just going to print it out and not actually run it. The letter spacing. Slate. X. Slate Y. Take our total width. It's 2 times slat width. All of that times the board scaling. So slat width pixels. Slate width, slate height. Front face width minus 2 times the slat width. Scale it down to our game size. Height minus 2 slats times the board scale factor. I think that's correct. Chalkboard letter spacing. I don't know what that needs to be. Renderer. Scale something, doesn't matter. Let's just say 10 pixels, just to see what we get. Size. So here's the equation. Ready? We're going 930. Well, the slate width, which is this mess. The width equals, I said there are 7 letter columns with a button column, so 8 times letter size plus 9 times the spacing. So if I plug in spacing, which is 10, that's 90. 90 from 930. Well, it's not even 930, but we can get a ballpark number. Well, it's not even 930. It's 24. 930 minus 24. Let's just call it 900. It's just ballpark of 900. And if our spacing is 10, there we go. 900. It's about 10 pixels per between each letter and the edges of the board. Then we really just get like 810 equals times the size, which means each letter's width. Is about 100? That seems actually quite large. Vertically, height equals there are 5 letter rows, right? 4 alphabet. Let's go 6. So I want a blank row. 6 times size plus 7 times spacing. And the height we computed at about 698. And the spacing is 10. $698 minus 70 is 628. 6 times size. If we divide by 6, it's again about 100. Wow. So we can have a lot more than 10 pixels. So the equation is size equals, oops, W minus 9 times spacing divided by 8. And it should be comparable in size to our height minus 7 times spacing divided by 6. Where our width is 930 pixels and our height is about 698 pixels. More cheap viewers. Lame. Nobody wants more cheap viewers. So we want. Maybe we just can split the difference, right? Maybe it's like a 60-40. So if it's 930 minus 9 times, let's just go 50, right? Divided by 8. How does that compare to 98 minus 7 divided by 6. All right, let's just check it out. 9 times 50. Yeah, that's a lot less space. 45. 30. 480 divided by 8 is 60. That still gives me 60 pixels right there. So this one is 7 times 50, 350. 698 divided by 658. That's actually quite a lot of room. That's more room than I thought I had. Means that I probably have room for a 55-point font size, which is already bigger than the tiles, which I'm okay with. Maybe we go 50, 60. Unless I've really screwed up my math, that's decent. Okay. Chalkboard slate width and height. Okay, the X is going to happen relative to the chalkboard corner. Basically plus the slat width. Oh, this is not my width. My width is minus 2 times that. And then shrunk way down. So 930. The slat width is 24, so 48. 48 times whatever this is, it's about half. So I guess 24. Mine is about 24. Let's just call that 900. Oh, do we want to math it? Okay. Now we have 2 times 24. Not this much. It's about 23 and a quarter. That's how much we subtract. So 930 minus Oops. 23.25. And 697.5 minus 23.25. So let's say 906.75. I'm mostly looking for like sanity numbers. And 674.25 should be able to craft a spacing thing here, which is what? Multiply 9 by our spacing. Let's call it 40, 45, 45. Minus 906.75. Seven times our spacing. Divided by 8. Divided by 6. Still around 60. If we go 45 pixel spacing, we're hanging out right around 60. Spacing is 45, 60. Which you can further simplify down and actually recompute dynamically. If we say that the spacing is 3/4 of our letter size, it kind of just gives us the numbers we want. Okay, now let's just keep this way. We can add a tiny amount of padding between the buttons and the letters, and I won't be sad about that. I think that's good. Is that good? These are hard-coded, but they can be unhard-coded a little bit. 930 can be hard-coded. Scale factor is fine. I'll do 0.3f. This is the target width. 930. $14.40 times the board scale factor. That's the board scale factor times the board scale factor. We need to talk about the width and the height, subtracting the slat, then multiplying that. Want to compute it this way? We surely can, can't we? This is that board scale factor here. So we take our width minus 2 times that times the scale factor. There's our height. Almost have absolutely everything we need to compute those. Although 45 and 60 just kind of worked out way nice. Take this height here. Let's do this. We like this math, but we're gonna take this term. We're gonna say spacing equals size times 0.75. Whenever we see spacing, we get size times 0.75. Now when we distribute, who knew math could be so fun? Size equals. I would rather do it on paper, but that's kind of not streamable. 7 times size times 3/4, which is really just 21 times size divided by 4 divided by 6. Yeah, some things are just easier on paper. 21s over 4 divided by 6 is the same as multiplying by 1/6. So it comes 21 over 24, which is 7/8 the size. Minus 7/8 size. Therefore, size equals size over 8. No. We have to add it. So it's 1 and 7/8 size. What's 8? So 1 and 7/8 is 15/8. 8 times height divided by 15. Yeah, I think so. Okay. So I think after all that math, I think this is the answer. Size is 8 times height. Times chalkboard slate height divided by 15. then the letter, oh, that's the size, not the spacing. And the spacing is chalkboard letter size at 0.75. If we've done all of our math right. What are the odds I did all the math right? Doing it in text documents is not ideal, but we can try it, right? Maybe. Cheap viewers, my gosh, the bots are out in force today. Holy smokes. All right, let's just try it. There we go. / layout math .py. We don't want to do it for the chalkboard. Near the top, which affects nothing else, we have these constants. We can put it in a sandbox scene. There. Agreed. Okay. Oops, semicolons. Always pain in my existence. Okay. In theory, that should give me a reasonable letter layout. So what do we need? We need 26 letters. We need 5 deduced letters. That's a good start. Sandbox scene, we're going to add those. Text, m_board letters, which will be 26 of them. And or alphabet. And solution has 5. Okay. Okay, so guesses. So there's the current guess, there's those things. 1 index equals 0 index less than 26 plus index dot rendered. So I should draw them. I'm gonna move the chalkboard somewhere else for now. A little bit above shelf. We're not working with shelf right now. Okay, so chalkboard. Blah blah blah. Chalkboard with an eye. Fine. Now, for each and every alphabet letter, we're going to get things so I don't have to type so much. Okay. Point to set alignment, which will be centered and centered. We're going to set the font. Font warehouse asset. Okay. Font warehouse asset. Pretty sure. Yeah. What eraser? Okay. What else we got here? We need to set the rectangle. We need to set the font size. Oof. Okay, font size. The font size can be pretty close to letter size. Maybe we take like what's this thing? I don't know. Matter. Okay. Okay. What else do we need? Okay. The position is going to be the hardest part. This one is easy. Okay, positions, which is really the whole point, right? We have a letter size and a letter spacing. So if we know the row and the column a letter is supposed to be in, we should be able to take letter index Ooh, okay. Well, okay. starting x is equal to the chalkboard slate x plus chalkboard letter spacing. And the starting y coordinate will be chalkboard slate y plus the same plus the actual chalkboard's position. So chalkboard x, chalkboard y. Chalkboard x plus the offset. Chalkboard y plus their offset. Okay, so we put each letter in, we say, oops, x equals start x. Remember we did this once, we were rolling out the other one. Y equals start y, okay. If index divided by 7 has no remainder, then x equals start x. This may actually have to go to the top. Oops. Put it at the bottom, I think. If the next row is gonna need a wrap, then we do that. Y equal plus equals. So letter spacing and our letter size. So we shift over the width of a character and then the space. Both down. Otherwise, we move x by that amount. This is not going to be at all correct, but it'll be fine. We move y down enough. So we hit the last one, it's not going to be multiple 7, so we need to pop a row, and then we want a blank row between the deduction letters and the alphabet letters. Is that going to be anywhere close to where we want to be? Sort of. Oh, we're only doing 5 letters instead of 7, so we're basically starting column 1. I think. Instead of column 0. Let's just try it out, shall we? See how far off we were. Yeah, the image warehouse is going to take a long time to build. We've got these huge images. It's all uncompressed by the time we get into the compile phase. We're going to have to do something about that later. But not today. Okay, a couple of issues. Oh. Okay, that shouldn't be too hard to fix. Unused values, not sure I'm really worried about most of that. We can remove those later. So it's just the way we're setting our font. Oops. I guess we do it this way. Okay. If this works at all, it'd be wonderful. It'd be glorious. Let's see. Where are we at? 3:30. Once we kind of get everything into the scene, it shouldn't be too hard to get things lining up neatly. In theory. Okay. Source builds, debug, sandbox. Okay, there's a lot of letters over here not doing what they're supposed to be. That is unfortunate. I was pretty sure we'd at least get something on the board here. So what did I do? Did I double scale a value? It's possible. There's my chalkboard. Chalkboard x plus that plus a letter spacing. Oh, I never set the rectangle at all. Whoops. X, Y, chalkboard letter, oops, size. Yeah, you gotta do that. It turns out, let's set the position if you want it to be positioned somewhere. Rocket science things, I know. That's how you get paid the big bucks. That's how you get the job offers at NASA. That sort of thing. Hey, there is a letter and it's way too big. I thought 60 sounded big. Although, is it scaling things wrongly? Shouldn't have been that big. I must have done math wrong. Let me remath. Did I delete my math? Oops. Okay. Well, here's the deal. Let's see. Where's my actual notebook here? I've got the note card. This one's probably big enough to need some actual math done. Or I can use scratch paper. Is this scratch paper? That'll work. Okay. So our height needs to roughly be equal to 5 rows, 6, 7 rows, 7 times our size, plus 8 times the spacing. Okay. And we decided that our spacing is equal to size times 3/4. Therefore, h equals 7 times size plus, oh dear, 8 times 3 all over 4 times size. H equals 7 size plus 24 over 4 size. 24 over 4 is 6, so it's 13 size. And h divided by 13. We should log it out, right? Whether it's size. Letter spacing. This is a problem when you do math in a text document. It just never quite works out right. I just can't seem to keep track of it unless it's on a yellow pad of paper. One of those legal pads, but not legal size. Hey, that's better. Okay. I mean, mostly better. We've got to step this across. We still have room for the buttons over here. We can even make the buttons a little bit bigger. So maybe make it like 1/12. We can make this bigger. That's just... (1/10). We're just experimenting here. Okay, 1/10 is too much, so let's go to 12. Down here, index modulus 2 is not 0. Do that. Otherwise, letter in there. Index plus doesn't matter. Okay. Okay. We still forgot to add things to that. So here, there. Oof. If a plus index is equal to u, I guess that happens here. Then we offset it one. I said it was 7, 5. Okay. Let's try that layout. Okay. Okay. That's not too bad. And there's like a blank row and then some buttons here. That's not a bad layout. And that gray is not an eyesore on the black and on the light blocks. These letters look comparable in size. Not like so different that you would notice necessarily. I actually think that's pretty good. I think that's our layout solved. So one question was, are we outputting any of that stuff? We were. So I have to update those. So in our sandbox scene, we decided on that. Yeah. So just so we don't lose it again, chalkboard letter size. There we go. Which means I think all this math can go away. Especially since half of it was wrong. Okay. Call that done. One more time just to be safe. Then we run it. We do need to check that it works on big screen sizes and small screen sizes. So here's the big screen size. Okay. If I make it small, which you probably can't see, we'll go in here. Oh, and it did not rescale. Oh, why did it not rescale? Did I make those static? These don't look static. I believe those all should have scaled. Why? But it's not because they were static at all. Oh. Ugh. We set center. That's the thing we do on every one of these letters. As in game scene. Set center on the letters text. Oh, just the letters, not on the. Okay, so letter. Set center at. I assume the compiler is going to pick that up and fix it. Which actually means half letter size equals that divided by 2. So we need those letters to rotate about their center. We still want it to line up with the ones below, even if those ones don't have to be centered. Sandbox. Oh, well, that's just wrong. Uh-oh. Okay. It's already scaled, that's why. So we scale those values. They're derived values, so magically that will work. We may be subtracting what we should be adding. Yeah, so we should add that distance. Or subtracting rather. Let's see here. Plus. And the center subtracts. That's right. So we need to reverse the operation. Okay, fair. And should be there. Boom. Good. So this is in our small scale. Looks fine. Go up to big scale. That looks fine. Okay. Then we still have room for some 3 buttons here. Good. Awesome. You want to do colory things? No, it's fine. Is that true? We probably should. All right, letter to index modulus 1, modulus 3, modulus 4 equals 0. Set text color. Game context normal. 1 will be reject color. 2 will be the accept color. Sure. Index equals 2. Set text color. That might be defining game scene itself. Oh. Huh. Deduct, deduced, letter clicked. Let's see here. Nope. Nope. Oh, let's see here. Swap. Where's my color? Do the select color. There we go. Right. Let's make sure that the colors have okay contrast with that dark thing. These are the default colors. We're not messing with them. Okay. The green, the red, those all look reasonable. The blue is reasonable. And visible. Okay. So there. I think that is pretty good layout as far as letters go. And size and clarity. So when I shrink it down to our smaller screen size, I don't see any major layout issues. Colors still show, the letters are still readable. 1024 by 768. Okay. So that I think is 99% of our layout. Added letter layout to sandbox. Letters are legible. I call add extreme. Screen screen sizes. We only tested at the extremes. Anything in between is probably fine. Okay, cool. Not bad, not bad. We're gonna save all that work. Source sandbox. Oops. Tools, layout, math. Added chalkboard. Letter layout. To sandbox. Oof, okay. Not bad, not bad. So where are we at? We want a ground plane. I think that'll break up the scene just a little bit, make it a little bit easier to see what's going on, or as far as perception of depth. And that's just a color quad. So I think it's time for a snack run. I need to do something besides chew gum. It gets old. But this is getting the layout down pretty good, I think. So be right back. Okay, and we are back. So, the hardest parts of the layout, I think, are done. I mean, it's not entirely trivial by any means, but what remains. But I think adding a floor plane will add a lot of, not, yeah, it'll add some depth. So let's just do that real quick to our sandbox. So that we have some visual breakup there. So there's the shelf. We set a rectangle and a color. We set our clear color. We set it to this, which I kind of want to change now. So let's go to X, Y, Z. So this is a blue. It's a very light blue. Nobody's going to ever have a school floor that color. Maybe like 64, 32, 16. Then our clear color, we're going to set to something more like an off-white. What's let's see here, hex or off-white or eggshell or off-white colors. That looks fine. Oops. Which only sort of helps. There we go. These three. We'll try that. So color up here. Floor. There we go. So the rectangle is, we will be at 0 frame height minus the margin. Oops. Frame height minus the margin. Let's shelf extrude height. Shelf extrude height. So basically, the bottom of the screen minus the 20 pixel frame margin that we have, and minus the angle at the bottom of the bookshelf. So I should put that line right at the back edge of that bookshelf. That's the Y. The width is the total width of everything. Frame width. And the height is this. We just need to render it before anything else. Let's render layout test. All right. Let's see if that makes it look more like a classroom. If we get it to compile. Oops. Okay. Well, it died because we didn't do this step. I don't know why. But I'm thinking clang has to stop being in my tool chain here. The fact that I have to clean every time I change the memory layout in a header file. Oh, maybe it makes sense. Let me think about that some more. No, not every time. Here we go. Boom. Well, that is off-white. That is a very dark floor. We can make that lighter. This back button won't be here, obviously. So we go to the current active game scene. There is space at the top. Hmm. This feels like a lot less space there is here. We could shift everything up. Basically increase the bottom margin. Hmm. Okay, well, it is there. I don't have a ground plane. We need a table. How hard do I want to work at a table? Which is not to say that the table Hmm. I'll leave a little more room for my table. Yeah, I don't think I'll be able to show all the legs of the table either way. I think I need to move everything up some amount. Not sure how much. Let's see what a table would look like. This is where the 3D aspect. Mm, I don't think I have a pixel ruler on this computer. I could just measure this distance. Or we could split the difference of the height of the shelf. We'd say, give us the render height. Let's center the shelf vertically. I want it centered. Um, Vertical offset equals. Let's move everything up 100 pixels just to see what happens. Plus a vertical offset, minus. XY with height. Ooh. Shelf Y. What are the odds I got that offset everywhere it needed to be? Oh, we did a clean. Okay. Okay. Well, um, looks like all of these were taken relative to the bookcase, and this is taken relative to the top of that, so we don't need to add it there. So, the chalkboard did need to move. This is taken relative to that chalkboard, so we don't have to subtract there. The shelf needed it. The floor needs it. I guess tiles are taken relative to the shelf Y, so we don't need to add it here or here. Again and again. Okay. Oops. I need to get that clean out of there. Okay. That's a little better. So, yeah, I'd say ground plane in. Now we need a table. Accentuate depth. Move everything up a bit. There is a lot of dead space at the top. Okay. We can change how much anytime we feel like, so I'm not worried about that. It's now just a constant we can change. So, ground plane to the same box and shifted things up. Okay. So we're going to the table. There's a few things we could do here. So the table could align underneath this thing like this. It could run off the edge. There's a few, yeah, okay. Sketch it. Maybe a sketch. That would be easier than one. Punk. Sorry. Didn't mean to shake your camera. Okay. Oh, paper slides. So one thing we could do is we could try to align the corners of the table with the blackboard. That's one thing we can do. Or you could run that off the edge, but it still would align on that, underneath that. On the other side, let's see here. So this edge and this corner would line up. Or City gave me all this budgetary information paper here. We have a blackboard, bookcase. Not really set up for art. There's not nearly enough room. We could have the table poke in on that bookshelf a bit and break up the line. Maybe something more like this. I think overlapping that corner of the bookshelf looks better. Although, in theory, that table would have to be forward a bit so somebody could walk behind it to get to the chalkboard. Or we could just abandon all hope of physically making sense. Spatially. Which may not be bad. Overlapping looks better. Is that screen aspect ratio fixed? Could put a little more space between the blackboard and bookcase with a wider screen. Have the table the same length as the chalkboard, slightly overlapping the bookcase. Yeah, I think if the right edge of the bookcase of the table and the right edge of the blackboard line up, that corner, the table, yeah, it doesn't make sense physically to walk behind the table and get to the blackboard if it's like laid out like that, but I think it'll look best. Break up the bookcase a little bit. That is a big big plane of brown that doesn't do anything. Okay, we can shoot for that. um, yeah. Times like these, I wish I had a graphics designer or an artist, but we'll make do. Okay. Yeah, we may end up moving things up more. Not just yet. Okay. This brings us back to our layout script. We're back into math mode. This table should only show up in game mode, so it's not like chalkboard. In fact, it's different enough that, okay, blah, 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 whatever. Table, 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 table. Oops. Okay. So we've stubbed in some table things. We'll just start with the standard browns. All we're doing is layout, really. I think later, well, we can make it a little more red. We'll make it more of a cherry red, right? So 5E, just make it like 8. Oops. 8 and maybe like a 7. Make some colors. So, our width and our height are not computed. Our depth probably needs to be at least the depth of the bookcase. Bookcase. Okay. Width, height, depth. This is just for the top plane. So the width will be 930, we said. The height can be, oh gosh, maybe like 12, 16 pixels deep. This is the top plane. The depth, cut around out at 125. Sure. We'll just see what that looks like. Updating the sandbox. We are writing all of that away. Those can go away. I'm going to write a cube though. It will be table top. Let's swap those. Literally nothing else really matters here. Compute the width, blah blah blah. Okay. Let's see here. print size, print object size. Give me an object. Something size. Table with object 1, 2, 3, 4. Object dot class dot underscore name. Object size of our block and our shelf and our board. Our table. This is all very similar except it's fine. Okay, let's just see what happens. So we're going to tools slash layout map time. Given the table, print object size is not declared. That's awkward. I'm pretty sure I did it right. Oh. There we go. Indentation matters. All right. Blah blah blah. We have some widths and heights of things. The tabletop is 3 polygons. I mean, let's just run it and see what happens. Okay. Yeah, the aspect ratio I have fixed. Basically, your standard default teeny tiny screen, you're kind of targeting 1028 by 768, and I decided I wasn't fooling around with aspect ratios, so I only took 4:3 aspect ratios everywhere, and I'm not varying from that at this time. Okay, so we have to go to here, go to Inkscape, delete everything, and run this. There, that is a tabletop. I was imagining like a darker brown red, but okay. That surely is a tabletop. $88 pixels. 88 pixels is not very much. Oh well. Let's see if we can make those colors any better. Actually, let's do it. Let's just do it here. More red, less everything else. Let's go 20, 24. Let's hear. D is what? Jeez. A, B, C, D. So maybe like 7, 1, and 3, 1. Like not 20, like 17. Not nearly as brown, more red, more darker. So we just cut these in half as well. 4, 4. Maybe a little on the dark side, but closer. 5, 5. Ugh. Yeah, sure, that looks great. Let's copy those colors to our script. We don't want everything to be all the same color, right? Okay. So the first question is, how does that even look in the scene? The second question is, we probably should add another polygon into this. So we want the thing underneath the tabletop. Okay. The thing up here where we did the face width height. And where we set X and Y. We're going to move things around here before doing that. These shouldn't matter. Okay. So tabletop. So there's always the thing underneath the table, the vertical bars, I guess. I don't know what they're called. The skirt, the table skirt, maybe. While we're coding, should probably be in Emacs mode. Okay. So we're going to come in some amount. Doesn't really matter. X plus equals 24 pixels. The width. Oh, wait. Keep those somewhere. Even if we're not using them. So X plus equals 24 pixels. The Y, we're going to come down our height. So we come down, but then we're going to slide. Oh, let me think. We want to. We just want to make a cube underneath this other cube. This one we know kind of works. Oops. We probably want a very dark. Where's the table? Or the shelf? Call this one very dark. let's see, basically cut everything else in half. So something like this. What was the first digit? 3. So 1, and then sure, it's probably fine. We want the top face, doesn't matter. This is the cable skirt. So we want it to be 24 over, 48 shorter, and shifted up 24 in the isometric direction. So is that like skirt offset or something? Okay, so here, skirt offset equals 24.0 skirt ISO width add ISO add width of 24 skirt ISO height okay, those are now variables. So our X is going to shift over 24. Our Y is going to shift up by the skirt ISO height because we're moving into the depth. Then our width minus equals skirt offset minus equals 2 times the skirt offset and the height also needs to be shortened. How much? I guess 2 times the ISO height. Oh no, the height is actually completely different. Oh, this is getting a little bit on the messy side. That's probably workable. I can foresee there are things I'm going to do that'll set me up. That's not what H does. Oh, this isn't even the right. Oh shoot! Hold on. The depth minus in pixels minus 48, right? So the height will be some amount. $24. Skirt height. I don't know. Pick a number. Kind of doesn't matter. Height equals the skirt height. Then we go from front face, mid, top doesn't really matter. Actually, dark, top doesn't matter, and very dark. Then we have to put our width and height back to the order. W equals face width. Height equals face height. And then wherever that extrude was, which is basically this. Oh, well, we'll worry about that. Don't worry about it. All right, let's run this out real quick. Just hear how it looks. So let's go to Inkscape. Delete everything. So in theory, that goes under the thing we just saw. It'll look great. So let's put that all back the way it was. XY with height and this cube. I'm getting to the point where I don't know what the actual image size is going to be when we go to the export, so that will be fun. Okay, we've moved down too far, probably because Y needs to move up. Delete. Run it. I can believe the X offset. The Y looks wrong. Okay. Oh. This is like a weird one-off. 0.3 float. We'll figure it out later. By 24. Basically how far we have to move it in for that offset, so okay. The skirt doesn't even really show up. Oh yeah, extrude width and height we have to change. So maybe 24 is too much. We go to 12. Float, skirt offset minus 2 times skirt offset x plus equals skirt offset. Y needs to move down. It actually needs to be a plus. No. Top corner edge of the table. You should come over and down. By some amount. Um, Need it. It would add some depth, so I do kind of want it. Oh, okay. Making another cube, I need to move down the height of the face height. And then again by the amount of the skirt offset from the inside edges of the table. Width is that, the height is that, so the extrude height has to be updated. Base extrude height. Width. Float of so add width the depth minus 2 times the skirt offset. Okay. Oops, that's not helpful. All right. Delete, paste, and go. See what happens. Okay, that's closer. That's closer. The widths look okay. It's the vertical still. Let's put this all back in here. So when we're doing the skirt, why? We don't move why. What happens then? Just need to move some. Nope, not plus. Minus. Um, oh, goodness gracious. Starting to drag here. What's going on? Okay, is it this then? Panel physically starts at the face height down, but then it has to move up some amount to indicate the depth. Sheesh. Move it that way by don't move the y at all. The face height, right? Um, um, that did not do what I expected. So I expect the y to be this corner here, which since it starts here, oh, well, it doesn't matter. If this is y from this, then when we say y plus equals the face height, that's this height. Face height is 16 pixels. I expect this line to be at the bottom of this thing. Except overlapping would work better. Okay, why don't we do this? Why don't we do this? Let's just do the tabletop. Let's not worry about the details. That's all basically let's just do this. Let's go ahead and oops. Let's grab this. Put it in here. We apply it. We get a tabletop. Um, I think the table will fit better in here. So let's go find the table, plop it in. Ooh. Glad it fits, but yikes. 11. Let's move this layer. Like 12. Let's just go to 1250. 1250. We can go. Yeah, sure, it's fine. Okay. Export. Scene elements 1. Okay. So I guess everything from here on out is probably Emacs mode for a little bit. Okay, so go to images. That block is now somewhere else. It's at I said 1250. Table starts at the x coordinate of 0. It's at 1050. The width. And the height. Okay. Sandbox. Texture underscore table. Where's the chalkboard? Set texture. So elements 1. It's a table UV. Then what? Set the rectangle to something. I don't really know what yet. But I think the width and height are those. The Y needs to be at the bottom of the chalkboard, so let's just start at chalkboard X, chalkboard Y, plus chalkboard height. This is nowhere near right, but let's just get it on the screen. So you're going to CD into our tools. Oops. Embed our new PNGs. Oops. This thing. Export as scene elements 1. Embed. Okay. Sandbox scene. We'll do a full clean on this one and just see where it shows up on the screen. Oh. Oh. As long as nobody thinks about trying to walk behind that table to actually write on the chalkboard, it should be fine. We want, yeah, we'll see. We're starting with something expedient. Where are we at? 5:15-ish? Okay, okay. You did not tell it to render to the table. A little bit silly of us, I know. Table should draw after the shelf and chalkboard. Sure. Nope. Let's just get our table width and height set away here. Probably something we need to output from the script as well. 1018 104. Okay, not chalkboard X. We're going to go to renderer print width minus margin plus table width. Let's try that. 930, 1018. It'll overlap by quite a bit. Maybe more than we want. But then we just move it down more, I think. Actually, that's not terrible. Or rather, I've seen worse. Other than the color selections, that layout's not that bad. Huh. It's not terrible. Now, this height, 104 pixels. That won't be very much when we want to put notebooks on them in a small scale. So I need to be able to fit 1, 2, 3, 4 notebooks on here. And have them be easily pickable in 2 parts. Like there needs to be like a pen and a notebook. Or something. Or just the notebook. We can left click, right click to do different things with the notebook. I think that's reasonable. So is that enough room for a notebook? I don't want to extrude out much more. Unless we move this over and start clipping off the edge of the table. If we move the table over and clip it off off the edge of the screen, we can make this a little bit deeper. This right here is all wasted space. There's nothing going on here. So the deeper we make this table, the better. That does mean scooching that off the edge, which I guess I'm okay with. So let's just lay it out that way. We're throwing on the table. Instead of the right edge of the chalkboard aligning with the right corner here, where's the shelf? Oops. There's the shelf. We're going to start at the shelf X. Shelf Y. Shelf width, shelf height. Did I have the shelf extrude? Width. Okay, that's the one I want. Okay. So instead, where's my table? Table. Start at shelf X plus shelf width minus shelf extrude width divided by 2. Then we can size it however we want. Basically, shelf X. What? Oh, and double. Okay. So, however much we grow this table down, which we might want to do by another maybe 50%. The table has a depth of, oh, let's add 75 to it. Let's make it 200. So this is the layout, math by for the table. Now we do all the graphical stuff. So over here we delete the tabletop, paste, apply. That might actually make this too wide for this one. Yep, it does. Okay. In that case, Export this thing. Back over here. Now we import the table. What, 1450? Okay, so elements 1 and 2 both updated now. So we this one goes back to 1050. This one was at 1450. And the width and height are now completely different. 1171 and 157. Okay. Then into sandbox. The table. It's in elements 2. Well, the layout math is all wrong anyway, so all we need to really do is update it according to what we outputted here. Okay. We probably have to do a clean. Yeah, this port image warehouse is going to get worked until we get that optimized. Uncompressed data. These days, so back in the day, there was the timing issues where it was faster to read a file than it was to decompress the data or to compress the data. Nowadays, modern CPUs are so fast, I think they've outscaled reading and writing from disk, so it's actually faster to compress it, write it, and then decompress it than it is to just write raw data, which is, we're doing the raw data thing. All right, let's do a full clean. We changed some things. Okay. Yes, we're in the fun stages of trying to polish, get good layouts where everything is visible, clean, reasonable spacing, the view is reasonably balanced, and what we need is visible. We can't really update any of our animations or transitions until we get that part done. Okay. So the table runs off the edge, but not as much as I thought it would. We can force it to run all the way off if we want. But I like this space better. Much more room for those 4 notebooks. It can be large clickable things. There will be 3 buttons here. We don't need to do much layout to make that look okay. Okay. I'm even okay with that table going off the edge. We can make it a scotch longer, I think. We want it more clipped. So the width, let's go out a full 1,000. Dot slash layout math by table. Oh, this part. Okay, updating the sandbox scene. That is the thing we need to do. Let's just do compute width for now. That's that will get more complicated as you go. Okay, that's fine. So we grab all this script, back to here, delete, run this one. Boom. Okay. This bad boy gets a new table. Oops. This one gets deleted. This one gets moved. Save. Export. So position is still the same, it's just the width that should be different. So if we go to here, images, the old table should be very, yeah, 1141. Sandbox. Okay. Oops. All right, embed PNGs. There's the 2 scene element ones. Those are the big ones. All these other small ones are going to go away in the end. To what? What are we doing? I guess we're not in Emacs mode right now, which we should do. JTL, have a good night. See you tomorrow. Thanks for dropping in. Always appreciate your feedback. I know you're much better graphical layout stuff than me, so thanks for the input. Okay. Because eventually what's going to happen is I'm going to take each of these images that I've generated, print them out, and use those as basically my outlines for doing something hand-drawn, I think. I think I'll just hand-draw something in like colored pencils, then scan them back in. As long as I follow the guidelines, it shouldn't have a problem with scaling. Everything should just work when we swap out those art assets. That's my theory. Sorry I spent so much time on layout now. If I have to go back and redraw everything over and over again, it's gonna suck. Oh, maybe that was a little too much. Pull it back in just a little bit. Yeah, maybe somewhere in between then. Width was 930, we went all the way to 1000, so that's we added 70, so we take 930 plus 35 is 965. We just come out 960. Oh, really? Oh, self. I can never remember which language I'm in here. Self, not okay. Okay. Back to Inkscape. There it is. Create our new table. Now the only two changes are these lines in sandbox. And that table width in images. Fed PNGs. Okay. Hope that brings the table close to being done. Tabletop, I guess. I still would like to have that skirt and some legs. It's not just floating. So what we really need is a skirt and 4 legs. Maybe not even 4 legs. We could maybe get away with just 2. I don't know. We'll see what happens. I feel as though something did not change the way it should have. Oh, I may not have exported the new image for that to happen. Which means this didn't happen in a way that picked up those changes. Oh, one thing at a time here. Okay. All right. Okay. Here we go. Boom. Okay, that table looks okay to me. Not the color choice, obviously, but I think we can work with that. All right, should we try to add the table skirt back in? And then add some legs to it. Those are the two things we kind of want to do. And we don't really have time to start anything too new with that anyways, so. Okay, so the skirt is going to be offset inside the table. So let's see here. If we look at the table edge on, right? It has some width and some height. Oops, what? No, come on, stop it, stop it. So something like this is if you're looking at the table edge on. And underneath it is another chunk of table, roughly like this. And the table legs come out roughly thus. So the table top, the table skirt. Usually the tabletop's not very thick. So we want to do something like that. Extend it out 3 dimensions. So when I'm saying the offset, it's basically how far from this edge to this edge. I think 12 pixels is good. So that's the skirt offset. So we have the skirt offset and we have the skirt height. 16? Let's go ahead and make those like other things. Okay. Right. Got those like that. And we want to do all of that before tabletop. So we want to preserve these numbers. Okay. And we need a new XY width and height just for the skirt. Skirt height, skirt offset. Skirt height in pixels. Skirt offset in pixels. Now the skirt depth is the depth of the table. So our table goes back some number of pixels, viewed isometrically. So we're going to go back that amount minus 2 times the skirt offset. So I think those are correct. We could get skirt width as well. Skirt width equals face width minus 2 times the skirt set. I don't even need a number for that. Well, the skirt offset, the skirt width, the skirt height. And the ISO is our depth minus 2 times the skirt. So that should give me a rectangle. So we set our X equal to, add the skirt offset, I agree. Our width equal to our skirt width. Our Y. This is a problem I don't like. Face height. If I do this, if I just move it down by the face height amount, one would think that our extrude height and width should be skirt ISO width and skirt ISO height. And we put our X, Y, width, and height back to where they were. Look at those. Y plus equals, so Y should move down. Alright, let's just see what happens. Width and height won't be right, but you know, that's part of the thing. Really? 57. Oh. Self.script offset. I knew that. There we are. We don't need to export anything until we figure out how we're laying this out. Okay, to OBS, to share the screen, to here, and apply. This is what I don't get. I don't think. All right. Here's what we're doing. Table skirt. The top polygon will make very dark. Select everything, delete, apply. So there's that big old gap in between. Frankly, this height doesn't look right. Skirt height. Oh, 16. Let's go like 24. It's like 36. Okay, that's more like it. Except that Y offset is really throwing me off here. So what am I doing with that Y offset? Okay. Skirt offset times 0.77. 0.414. XY width height. Huh. 0.707. So is that what I needed? I guess that back corner's clipped anyway, so it doesn't really matter. So maybe that's fine. The only thing this does is extend the height. So what does this look like? This looks like minus equals. ISO add height. Self dot skirt offset. Okay, so when we compute our height now, it's actually more complicated. Not the width. The width doesn't change. The height, though, is going to change. Height plus that. Plus. Ooh, plus. That's just the tabletop. Now we have to add the skirt, which has self dot skirt height minus ISO add height. Skirt offset. Maybe. I think it's only used there. Who defines size? Let's try that. Although we're running out of time, so we may have to pick this up tomorrow. And then we have to decide whether to where we're gonna go next. Basically, once we get this table put together, where to go next? There is a problem. Y minus equals something weird. Oh, come on. Oh, not D, F. There we go. Okay. Do this real quick. And there's a table, although that... Huh. Oh, skirt height is still wrong. 36. Yeah, 36. So in here. There we go. Okay, so that's our table, more or less. We'll throw some legs on it tomorrow, and then either draw out the journal books the same way that we're doing now, so that they all fit and line up, which is probably a good thing. That's on our list of things to do. Yeah, so I think that's where we're at. Not too shabby. The chalkboard all laid out. I'm happy with that. Got the table mostly laid out. We'll throw the legs on and slap it in tomorrow. So thanks for joining me. You have a wonderful evening. Thanks for all the chats and participation. And I think we're going to wrap it up there. So have a wonderful evening. See you tomorrow. Bye-bye.